people out there who want to learn new things. So thank you for that. And let me start. So basically, I would be going ahead and discussing three projects on what helped me, like what I believe as real world challenges and how it helped me, and how you can grow your path in AI for, like real world problems. So I have three case studies. Moving ahead with the first case study is applying AI to analyze domestic violence during COVID-19 in India. So, what's the problem? The problem is something which all of us know. Indeed, that COVID 19 has shown a remarkable increase in the number of domestic violence and online harassment cases, right? All of us would have also come across that situation where we got to know from our neighbors or say friends or anyone that, okay, so and so happened, and uh, we have seen people becoming victims to domestic violence and online harassment, especially during the lockdown stage. But the challenge over there is that most of the domestic violence cases are reported via calls, and thereby it makes the data and subsequent mapping difficult, right? So it becomes difficult to report. Even you report your incidents via calls, how are you going to track and how are you going to know? So that's the problem. And what we were to do as a team was to basically perform a data mining analysis regarding an increase in the online harassment and domestic violence during COVID-19, and then perform a qualitative analysis. Now, first, it's not, the first problem is data. Only if you get the data will you be able to build a model to analyze that data. And data over here is difficult because most of the cases were reported via calls. So, moving forward, this is the data. So when we talk about domestic violence or online harassment, it's going to be more of textual data that I'm talking about, text data. It can be from Twitter, Instagram, or just a minute, my video is just taking a, yeah. So it can be from Twitter, it can be from news, it can be from Instagram, it can be from Reddits, it can be from a lot of sources. Now, how are you going to determine those sources is the first question. We all know that we will not be able to get the recorded data. So our next option would be to get the data from online resources. And from online resources, even we have huge number of online resources, right? We have social media, we have reliable media, we have Google Trends, we have Reddit, we have so many. Like we also have government data. Among them, how will you choose data to choose? So here, what we did was a part of the project. We basically relied on three types of main data. Three types. The first set of data was newspaper data. By newspaper data, what I mean is that, just a minute, Ali, yeah. So by newspaper data, what I mean is that, in newspapers you have a high efficiency of, say, like, you will be going through reliable data, isn't it? You won't have any opinion based in newspaper. It's more like so and so happened in so and so industry, and it took place here. It's going to be like that. But social media consisting of Twitter is exactly different. Sometimes you won't even know if that occurred or not, right? But it's more of opinion based. Social media is more of opinion based. So basically, we have social media, we have reliable media, and the third one is government data. We do have a set of government rules and regulations where we have few people. Sorry that I am. Audible problem? PM, am I audible?
Yes, yes.
Yeah, thank you. I was just like, yeah, thanks. So, yeah. So what I was saying is we have reliable data, we have social data, social media data, and the third one is government data. Now, what is the power of government data is we have the numerics, we have the statistics as to so and so cases were reported last year with the help of police station records, and but we cannot analyze with them. We cannot perform a qualitative analysis, but can do a quantitative analysis. What I mean to say, basically, five there are any numbers and what's the growth and work on that, but you cannot do a qualitative analysis if you get statistical data. So we finalize on three types of data. We get social media, we get reliable media, and we get government data. Moving forward, right? So this project is a very, very good example of how data is very important and what should be done if you have to overcome data challenges, because we did not have we had absolutely zero data to start with. We went on to build our own data set. Instead of building a model, we went on to build our own data set, isn't it? So basically, we build the data using we choose the source, we collect the data, we pre-process the data, we check the validity of the data, and then integrate annotations, data set preparations, everything. But let's move step by step, where I can explain step by step what's happening. So the first part is when you are building the data, right? You choose the sources, and we have already chosen, right? We have chosen social media, reliable media, and government data. In social media, we took Twitter and Reddit into account. Instagram has a few privacy policies, thereby you will not be allowed to scrape data. After that, secondly, newspaper data. Because this project was based out of India, so we scraped data from Indian newspapers, both English and non-English newspapers. All that. And then the third one is government data. Government data was quite straightforward. If you just apply a filter called domestic violence, you will get the number of cases related to domestic violence. So now, we are done with the source and we've collected the data. Now the question is, how are you going to collect the data pertaining only to domestic violence and online harassment? If you search in the newspaper for, say, the period from Jan to May 2020, you are going to have millions of texts, isn't it? The data will be from sports, politics, and a lot of other things. But that's not the case over here. So, what we do is that you have to have a special keyword, right? You need to have a special keyword, say, like domestic violence or slap or abuse or harass. These are the special keywords which will give you the text which is related only to domestic violence and online harassment. So after you are done collecting the data based on so and so keywords, you will need to pre-process it. And what's it pre-processing and validity? Now, whatever data you collected, you can't be sure that all the data is going to be similar to uh, whatever data you collected doesn't mean that it's going to be domestic violence and online harassment. It can be other, not domestic violence, but some other type of violence. So that's where you need to pre-process and validate. You need to look at the data. And what we did was we performed a few topic modeling algorithms. Why did we choose topic modeling? Because it's an unsupervised means and we had loads of data. So we applied topic modeling algorithms to basically understand, what's happening and things like that. After we applied topic modeling, we were able to filter out a few data, and after we filtered out only the relevant data based on the topics like women, domestic violence itself, we were to work on integration of data sources. Now, as we already told, we collected data from so many sources, right? They're all unrelated. Social media and reliability in media can never be the same. There is a problem over there as to how do we integrate from different sources. So that's another major challenge that we went through, where we had to define labels, particularly where it can fit a broader perspective. And after we're done with integration of data sources, next is annotations. So annotations, I would say that it's like an underrepresented one, because annotations is the backbone of a lot of social media. where we don't have a proper, now in this case all the data was from scraping and we did not have a proper data set. In that case we built our own data set, and annotations is a way that we teach the machines to talk. I'm sorry, annotations is a way that we teach the machines to actually work on it. So basically, after we are done with annotations, we move ahead with the dataset preparation. And again, in annotations, there are two types. One is you try to annotate for a classification level, and the other one is you try to annotate to get like a named entity recognition. By named entity recognition, I mean that perform a qualitative analysis. Two types of annotations. One is get the topic or get the label the data belongs to. If it's domestic violence, online harassment, or sexual abuse, get those. Second is qualitative analysis, where from each text you will find out who is the actor, who is the victim, what is the age of the actor, what is the age of the survivor, and what relationship they share. These are supposed to go through them. So now, like I mentioned, right, these are the attributes that we labeled for qualitative analysis. And we came up with our own labels. The reason was that age of the actor, right? Now, abuser's age is important to see what was the age group, age of the survivor, what is the gender of both the actor and the survivor, and then the orientation, and then the time and the relationship. The relationship is what matters the most in domestic violence. You need to know which relationship the actor and the victim shared, and then the place where the incident took place. By knowing the place, you will try to understand which which place is more unsafe or safe or things like that. And then the circumstance and the medium violence, the violence verb, and is the actor or the was physically or mentally challenged. Now there was one such scenario where the son went ahead and killed his mother because he was not in a proper mindset. The son went and killed his mother because he was not in a proper mindset. By proper mindset, I mean that he was mentally challenged. He was not in his senses. Thereby, he lost control and killed his mother. So that comes under the challenged actor. Now, when we talk about this entire project of domestic violence, right? What are the main things that we focus is first, when you are given a problem, identify what type of data is required. After you identify what type of data is required, for example, text or image or video, then next step is identify if you can get them online, if you can get them locally, without paying or anything like that. After you identify those sources, get the data, and whatever data you get that way is not going to be clear. It's not going to be clean at all. You have to make the data clear. In that process, try running a few topic modeling algorithms and then perform annotations so that you can leave out the unnecessary data and have the necessary data in. All right. And then get labels, get these information from the piece of text. Now the label circumstance is going to help us a lot in identifying what to understand if COVID was the reason behind a lot of domestic violence cases. Isn't it going to be helpful to the government? So this is one such label which we need to think. These are the labels that we need to come up with. So just having a small summary, it's important to get the data source, and then after you get the data source, collect the data, do a bit of cleaning slash pre-processing, and then use your creativity. By your creativity, I mean get your labels. See which labels will help you to understand the data better. So get all that, and by then you will be done. So moving at the second project, I believe we can, even if we have questions, we can discuss it, like during the last 10 minutes, the last phase. So the second project is applying AI for increasing solar energy adoption through roof detection. Now this case study again, firstly, this is related to renewable energies, right? By using solar energy, we are trying to get more, we are trying to reduce pollution. And this, we are helping them to by making their cost easier. So what does this actually mean? So during the COVID-19 or any time, right, if you were to install a solar panel, what would the company people do is they go to the houses, and then they check the obstacles, they check the material, they do all that, and then they come back and decide as to what is the area and basically plan out. But during COVID-19 it's really difficult. During the lockdown it was pretty difficult to go to each home just to analyze that area, and it of course takes up a little bit of money. So what we can do is we can come up with an algorithm so that you can actually try to build you can try to build a model where it automatically checks where's the rooftop, where's the obstacle, etc. And then you can plan out for various stuff. So our goal was to detect the rooftop from the images, the type of rooftop, the area, the material, and the obstacle area. All this is important because then the solar company will make use of it to get it further. Now, the first part, what I would like to introduce here is a term called as satellite imagery. So when you take satellite imagery is it's going to be capturing a lot of houses. It's going to be capturing a big area. That is satellite imagery, and you have to perform tiling so that you can use this. You can use this and further work on things. Was someone going to say something? Okay. So the tiling is done so that you can perform algorithms on on images like this. If tiling was not done, it's going to be one full image having all these tiles. So moving forward, again we used annotations here. We did not have a label data set, right? So we try to annotate the rooftops, as you can see here, right? We try to annotate the rooftops. And after that, we tried applying rooftop detection algorithms or deep learning models, where we try to detect the rooftop and its type. So by doing that, we are going to get our this. So, for example, if you look at this purple color, right, it says it's flat. It's flat by 0.97 probability, and this is the particular rooftop. So it's going to be the detection of the rooftop and then also the type of the rooftop. Moving forward, we went ahead and tried to get the material of the rooftop. And after getting the material of the rooftop, we also worked with the orientation. Orientation is also pretty important because you need to know which side the rooftop is facing, and so that you can go ahead with solar panel installation. This was done using computer vision algorithms. So a key takeaway from this entire project is that, again, the power of annotations. And for the detection and the type of rooftop, we used instant segmentation models like mask RCNN, Detectron 2, and ULACT. Afterwards, where we had obstacle detection. Obstacle detection is a very challenging part because in every rooftop, obstacle can be different. In one rooftop, it can be a water pipe. In another rooftop, it can be, say, a small shed. You will never know what an obstacle in a rooftop can be. It can be of different types. So we tried to combine everything together, and then we used a few computer vision algorithms, and then we calculated the area of the rooftop using the number of pixels. This was going on with the solar rooftop project. The third case study that I would like to introduce is preventing malaria infections to topography and satellite image analysis. So now again, the term satellite image, what does that say? You're gonna get a huge file, a huge image which covers one entire city. And what we have to do, we have to pre-process that because we can't be working on that entire image, right? So we need to pre-process that is cut down into small images and then start working. So when it comes to malaria detection, isn't it? You can do that in two ways. One is image data, and second one is non-image data. Looking at the image data, you can tell where a water body is located, and based on that, they will decide as to what can be done. Right? So they will decide on the, if they see a water body, they are going to decide, they're going to see that, and then decide, okay, if there is a larger water body here, means that there is a larger spread of malaria which can happen over here. So that is one. And apart from that, you have the non-image data. Non-image data includes conditions like population density, the land distance to the water. So how does that play an important role is, the population, if the population is low, it's not going to be a problem, right? Like if it's very low and then you have a lake, sometimes the risk will be less of the malaria spread. But imagine you have a huge population near the lake, that time you will have to suffer definitely. So we took that into consideration, and we took the distance. Say you have a lake far away from the land, it's really not going to be a problem, because mosquitoes wouldn't travel such a long distance and come to spread over malaria. So these are the two ways that we can see this project. One is use image data, and the other one is use the indirect features. And this is another factor where you calculate the vegetation index. It tells you, it helps you to enhance the contribution of vegetation properties, and allows you to compare things. Based on vegetation also, you will be able to prove if there will be malaria spread or not over there. This is the entire set where you have data sources, extraction model, raw data, pre-processing, feature, everything. Again, when you have to summarize this entire project, you will have to tell that first get the data. After you get the data, pre-process the data, because that data cannot be applied to your algorithms just like that. And after that, try to apply a few algorithms. And after you apply those algorithms, where you get the vegetation index, where you get the water area, everything, and then predict risk maps. Tell how risky that area is for malaria spread. Right. So yes, I would just like to take a pause at this point to know if we have any questions.
Well, thank you very much. Thank you. Any question, please? I know we have questions. Any questions? Any question, Esther? Any question,
So
Babatunde?
please do not hesitate to ask questions, because I was also in your place one day, and so it's always good to ask questions.
Okay, yeah, I understand. So, any question before we continue? Probably there's no question for now, so let's continue. And I got this information from Zoom that the meeting will end in 10 minutes. So, should in case it ends, please let us reconnect. But nevertheless, let's continue.
All right. So if there are no questions, then I just have a few more things to say. So basically, whenever we do things with artificial intelligence or machine learning, when you try to implement a convolutional neural network to predict if the image has a cat or a dog, that is going to be something unreal. Right? That's going to be something unreal. You're not going to understand what's happening there if you work on a project which is going to detect a cat and a dog. So my humble advice, or for people who are willing to pursue proper career, I suggest that please work on real world challenges. Something which, it's not necessary that the project has to have an impact, but it's something real. So you will know from phase 1 to the last phase. So you will know, okay, for this real world, where am I supposed to get the data? From building the data to deploying the model, you will know all things. You will have various steps aligned in that. So I would suggest that participate in more projects where you work with real world and real time more than working with other things. And that's what I have here. Do we have anything else from others? Any questions? I'm open to any kind of questions. If it's, career switchers or career starters or experts, I would love to hear from your end for your questions, and I'm always ready to answer.
Okay, okay. Is there any question? While waiting for other people to ask questions, I have a question. So I want
Sure.
to. Okay, so I want you to. How do you know the right algorithm for solving a particular problem? So how do you get to know the right algorithm to use?
Okay. So, in when you have a say when you are just having an AI project, and when the most important part, right? Many people do not look at this way. The AI model is comprised of 40% where you try to understand the problem statement. So,
Mm,
my thing over here is do it in three steps. First, understand first before you, as soon as you read your problem statement, understand what type of data has to be used. Number one. Yeah. So get that. So if say that I want to use textual data, I'm having text. Read the problem statement and see what is your end goal. Are you trying to classify data, or are you trying to analyze the data more? If you mean by analyzing data, it means that more and more you're looking into the data, and you're saying that okay, this is the name, this is the actor, this is the victim. Do you want to analyze the data more? If you were to do that, it's called feature extraction. So try to apply feature extraction models. So after you get the data, your roadmap is like try to apply information extraction. But there is another set of projects where you need to classify the data, at where you want to classify the data. If the data belongs to sports or if the data belongs to politics, in that time use a classification algorithm. So when you look at the problem statement, you need to understand if it's qualitative analysis or if it's a quantitative analysis. By qualitative, I mean feature extraction. By quantitative, I mean graphical representations, visualizations, calculations, and classification set. Which category it comes under? Ideally, it's going to come under these three categories. So once you figure out that, the roadmap is going to be easy. Did that answer your question? I'm not sure.
yes, very well. Yes. So from what he said I should first understand the data.
Mm-hmm.
Then this will let me know the type of data that I can extract from
Yes.
the from the internet. And you said that Instagram do not give us access to extract
Correct.
data. Okay,
Correct.
so that means that I will have to understand where I'm going to get the text, where
Yeah.
I'm going to extract my data, newspaper, and you said government
Mm. Data. Yeah.
data
So
is
government
very easy.
data, yeah. So government data is actually provided by most of the governments in a few countries, where they show you statistics of how many cases happened last year, this year. So they have proper numbers, number representations.
Wow. I can just I can just message government body, anybody in charge that, and they will release data to me.
Mhm.
Okay. And then secondly, you said I should read the problem statement, and
Mhm.
I should understand the end goal if I'm going to be analyzing or classifying my data.
Yes. Yes.
Okay, okay. So I got that. So thank you very much. So from there, I'll know the type of algorithm to use, whether
Mhm.
if if I'm able to understand the end goal, where I'm actually going, what I
Yeah.
want to achieve.
So how it happens is once you're able to understand the end goal, imagine it's information extraction. There are a lot of algorithms for that, and that is going to be via trial and error method. Because
Okay.
from the algorithms that will help us in information extraction, we don't know which will give you the best result. So we try and use every algorithm in that and see which gives the best result. But ultimately, deciding the major one is the point, if it's classification or if it's information extraction. Based on that, we can think of machine learning models.
Okay. Wow. Thank you very much. So any other question? Any question of any Any question, gestures?